When I draw my right triangle, the perpendicular has to go to the x-axis. Now at this point it's easy because since I know that point right there, I do my perpendicular from that point. So that I know this side of the triangle is -3 and this side of the triangle is -4. Now, I know sides of a triangle can't be negative, but it's going to help me use the negatives in the right spots if I go ahead and label them negative. Because I went left and down. Now, doing the Pythagorean theorem, I can find my hypotenuse. I'm ignoring that. I dropped my perpendicular from that point. How long will my hypotenuse be? Do your Pythagorean theorem. Five? Yeah. 9 plus 16? Now, x can be negative, y can be negative, but our hypotenuse is always positive. This will never be negative, so this is always positive. These diagonal sides, the hypotenuses, will always be positive. X and y can be negative depending on the quadrant that we're in. So now what does that mean for my sine and cosine and stuff? Well, I'm going to do it all the same, but some of them are going to be negative. The sine, remember, theta is always at the origin. This is where we're always basing opposite and adjacent from. So sine is going to be -4/5. -4/5. Pythagorean theorem. A squared plus b squared equals c squared. 9 plus 16 is 25, and the square root of 25 is 5. Now, what's the cosine? Well, it's adjacent over hypotenuse, so it's -3/5. And the tangent will be -4 over -3, which is 4/3. The negatives cancel for the tangent. And then the reciprocals, same thing. So -5/4, -5/3, and +3/4. Nothing different about that problem except we're in a different quadrant. And when we're in a different quadrant, we're going to have some negatives. No matter where you are in 2, 3, or 4, you're going to have some negatives involved. All right, let's try B. B is in quadrant 4. So I'll draw my triangle in quadrant 4. Always the perpendicular goes on the x-axis. And my point is 3, -2, which means the x side, this is the x-axis, so the x side is 3, and the y side is -2. Now, what's my hypotenuse? Figure that out. Pythagorean theorem.
Square root of 13.
What'd you say?
Square root of 13.
Yep, square root of 13. That's exactly right. A squared plus b squared equals c squared. So it's the square root of 13. Now your angle is always the one at the origin, so that's how I'm figuring out opposite and adjacent. So what is my sine?
-2/3.
-2, not -2/3. -2 over root 13, because it's opposite over hypotenuse, or -2 root 13 over 13. What's my cosine? 3 over root 13, or 3 root 13 over 13. And now, what's my tangent? That one's -2/3, right? The tangent is -2/3. So now I'll just do my reciprocals. So -root 13 over 2. Remember in a fraction, fraction, it doesn't matter where you put the negative. Just gotta make it negative. So root 13 over 3 and negative 3 counts. Okay, now I want you to get your yellow sheet out and just look at something for me for a second. I know we've been using sine. Sine has been opposite over hypotenuse. But what is that other definition of sine? Y over R. Now wait a second, guys. I want you to make the connection. Notice that in this picture, for this problem, the sine was a negative number, but the cosine was positive. Why does that make sense? Because in quadrant 4, x is positive and y is negative. X is associated with cosine. So if x is positive, cosine is positive, and y is associated with sine. So if y is positive, sine will be positive. Kind of see how that starts to fit together with the pluses and the minuses? Remember, your hypotenuse is always positive. So the SIGN of your SINE is going to depend on y, period. Because hypotenuse is always positive. Okay? All right. Now, part B is exactly the same thing, except they didn't draw the picture for you. So this should not be an issue for BA, I guess. So for BA, we have the point is 2, negative 2. So I'm going to just label my triangle like that. Now, I have done this so many zillions of times, that triangle comes automatic to me. I need you to remember that every triangle you draw is going to be one of these. Do not draw any other triangles ever. If the point is in quadrant 4, then the picture you draw is going to look like this. What's my hypotenuse? Square root of 8, which actually reduces to 2 root 2, and we should reduce it. Read?
Does it matter if you do like the triangle like quadrant 3 or something like that?
Well, yeah, the point is 2 comma negative 2. Where is the point 2 comma negative 2? Over 2 down 2.
Oh, okay.
It has to be in quadrant 4. Yeah. You don't get to pick your quadrant, ever. You have to use whatever point you've been given. Now, this time we're going to have a little simplifying to do. So when I do my sign, it's going to be negative, and it's going to start out as, I'm going to do it over here, negative 2 over 2 root 2. Would you agree with that? Now, these will actually cancel and leave you with negative 1 over root 2, which then we have to rationalize and get negative root 2 over 2. So in the beginning, we had opposite over hypotenuse, negative 2 over 2 root 2. We could just cancel those 2's out to make our life a little easier. That left us with negative 1 over root 2, so then we rationalized. When I do my cosecant, I'm going to flip it right here. Does that make sense to you, that that would be the best place to flip it? I could flip that, that, or that. This would be the easiest for me. Negative root 2 over 1 is my cosecant. Now what about my cosine? Won't my cosine be exactly the same thing, only positive? So it's going to be 2 over 2 root 2, which is 1 over root 2, or root 2 over 2. Exactly the same situation. And then the secant will be root 2 over 1, or root 2. And what about my tangent? negative 2 over 2, which I'm just gonna write as negative 1. And then the reciprocal will be 2 over negative 2, which is also negative 1. One more quick thing, and then we'll wrap up and spray. How big is that angle right there? You should be able to tell me. How big is that angle? 45. Kids, I know the ratio is 1, 1, root 2, but everything here's doubled. That's a 45, 45, 90 triangle, because see how these two sides match? Doesn't that mean the angles have to match? And they have to be 45. So anytime these numbers match, you're going to have a 45-degree angle. So you just found the sine, cosine, and tangent of 45 degrees. All right, so let me mark down where I'm at here. Let's get this out of the way of the front door. And